Unit 5.3, increasing and decreasing intervals. Find the critical points of the graph of f. When the slope of a function is positive, the function is increasing. When the slope of a function is negative, the function is decreasing. So first, we're gonna put down all our points with extrema. So right here will be 3, and then 5, and 6. Now you'll notice I put spaces in between each of them, and in between these spaces we'll put the domain of every other number. So negative infinity to 3, 3 to 5, 5 to 6, and 6 to infinity. Now we know the sign of f prime of x of each of these is, so since it's a horizontal tangent line, we know these are 0. Since this is a point, we know that this is D and E. And for this instance, by looking at the graph, we could tell that on this interval is going positive, and this interval is going negative, and this interval is going positive, and this interval is going down, so negative. Number 1, find the intervals on which the function f of x equals negative x squared minus 4x minus 1 is increasing and decreasing, and justify your answers. A, first find the critical points. So we know that we just have to find the derivative, which is negative 2x minus 4. And whenever this equals 0, since you cannot make this function not exist, so just whatever value we put here and make it 0. So this is x equals negative 2. In between the x values, the derivative must be positive or negative. We use a chart to help keep track of the information. Write the critical points of the derivative first. So we only have one critical point, so we'll put negative 2 bars, and then remember you have to put the domain of every other number, so negative infinity to negative 2, negative 2 to positive infinity. That's over here. So to find the sign of f prime of x, we have to plug in a number within this domain and a number within this domain into our function, our derivative function. So for this, we'll use negative 3. Negative 3 is positive 6 minus 4, which is positive 2. So since it's a positive 2, we know that the sign of x is f of x is positive. And right here, we'll do 0. Plug in 0, it's a negative 4. So since that's a negative number, here's a negative. Answer the statements with justification. So our justification is going to be f is increasing on negative infinity to negative 2 because f prime of x is greater than 0. And f is decreasing on negative 2 to positive infinity because f prime of x is less than 0. Find the intervals on which the function f of x equals 1/3 x cubed minus x squared minus 15x plus 2 is increasing and decreasing, and justify your answers. So first we have to find the derivative of our function, which is f prime of x equals x squared minus 2x minus 15. And then define, since again we can see that we cannot make it does not exist, so we know that to find when our x values are zeros, we just have to factor this out. So this is x minus 5, x plus 3. And our critical points are x equals 5 and negative 3. So we go over here, we plug in negative 3, 5. Then we write down the domain of everything. Negative 3 to 5, 5 to infinity. Now this is 0. And it's the same thing where we plug in the numbers. So we'll go -4 right here. -4 minus -9 times wait. -4, plug it in here, it's -9. This is 3. So times a -1, which is a positive number. We'll do 0. So -5 times 3 is a negative number, so we know this. And then we'll do 6, so 1 times 9 is a positive number. Answer statements with justification. F is increasing on -infinity to -3 and 5 to infinity because f prime of x is greater than 0. F is decreasing on -3 to 5 because f prime of x is less than 0. Graph of f prime, is f increasing or decreasing? Determine the intervals where f is increasing and decreasing based on the graph of f prime. So we know that if it's positive, then it's increasing. If it's negative, then it's decreasing. So everything above the x-axis right here, so this line and this line, is increasing. Everything below is decreasing. So we just write -infinity to -3 and 1 to 3 because f prime is greater than 0. And down here we put -3 to 1 and 3 to infinity because f prime is less than 0. Application of rate of change. If you want to know if something is increasing or decreasing, you look at the sign of its rate of change. The sign of a rate of change can tell you if the dependent variable is increasing or decreasing. Interpret the following. So students is our y value, or dependent value, and years our x value, or independent value. So students over here is greater than 0. This means that the number of students per year is growing. Same thing over here, since it's less than 0, that means it's decreasing. So the number of miles per hour is decreasing. The number of mastery checks per week is increasing. And right here is the number of virus cases per month is decreasing. Number 4, the rate of change of fruit flies in Mr. Kelly's kitchen at time t days is modeled by R of t equals 2t cosine t squared flies per day. Show me that the number of flies is decreasing at time t equals 3. All we need to do is plug in t equals 3 into the equation. So R of 3, and you might need a calculator to do this, is -5.466, and that just continues. Now we could say that it's decreasing because R of 3 is less than 0.